I believe you are really alive and you want to know about the world you live in. I'd like to help you with that. This video contains the basic knowledge you should have about our universe. Physics doesn't answer questions beginning with word why. Physicists divide universe into parts and describe how different parts interact with each other. What we know about so-called matter are just features of these parts. This division is artificial. According to quantum physics, elementary particles are described by a wave function that has non-zero values even at large distances from the place where the particle is most likely to be found. So, we can expect that this way of describing the universe is not accurate and leads to great errors. We don't know what matter is, and we don't know if matter has other more subtle features. We don't know what it means to exist. We found out that features of one part of the universe could be transferred to other parts through a process called interaction. It turned out that the interactions take place through transfer of particles between the neighboring parts of the universe. These particles are carriers of certain features such as momentum, energy, charge, spin, color in interactions between quarks, and several other features. It has been proved that every symmetry corresponds to a conservation law. Invariance with respect to translation in time corresponds to the law of conservation of energy. Invariance with respect to translation in space corresponds to the law of conservation of momentum. And invariance to rotation corresponds to the law of conservation of angular momentum. The law of conservation of electric charge is more difficult to understand because it results from the invariance to the gauge transformation of Maxwell equations. The laws of conservation of energy, momentum, and angular momentum are true because the laws of physics do not change if we translate in time, space, or rotate. We should add here that because of expansion of the universe, law of conservation of energy is true only locally. It is not true for the universe as a whole. The carriers of the electromagnetic interaction are photons, carriers of strong interaction between quarks are gluons, and carriers of weak interaction are W and Z bosons. We suspect that gravitons are the carriers of gravitational interaction, but so far they have not been discovered. Almost all matter we know is made of electrons and two quarks, up quark and a down quark. According to theory of elementary particles called Standard Model, all particles are massless. Electrons and quarks gain mass through interaction with Higgs field. Proton is made of 2 up quarks and 1 down quark. Neutrons are made of 2 down quarks and 1 up quark. The mass of quarks accounts for only about 1% of the mass of a proton or neutron. Most of the mass proton and neutron gain from kinetic energy of moving quarks and potential energy of interaction between them. According to Einstein's formula, energy equals mass multiplied by c². So, mass equals energy divided by c². We can see that the relationship between mass and energy is really real. Most people, however, believe that it works only one way. What has mass has energy, but it turns out that also what has energy has mass. Astronomical observations of the movement of stars in spiral galaxies and observations of the movement of galaxies in galaxy clusters show that they are moving faster than allows the force of gravity, the source of which is matter made of quarks and electrons. An attempt to defend the laws of physics is the concept of dark matter, which interacts with matter known to us only by gravity. So far, we have not discovered dark matter particles. Some physicists are trying to modify the general theory of relativity describing the gravitational field, but to date, none of these attempts has been successful. 100 years ago, Edwin Hubble introduced the theory that the universe is expanding evenly in all directions, and this discovery was a big surprise. Then, in mid-1990s, it was proved that the pace of expansion of the universe continued to accelerate, caused by a property called dark energy. Currently, the latest measurements of our ever-expanding universe suggest that it is growing faster than astronomers previously thought. The universe was found to expand 5 to 9% faster than predicted. This surprising discovery could be an important clue to understanding this mysterious part of the universe, which accounts for 95% of everything and does not emit light, such as dark energy, dark matter, and dark radiation. This could mean that dark energy is pushing galaxies apart even more. Or the early cosmos may have contained a new type of subatomic particle known as dark radiation. A third possibility is that dark matter, the invisible form of matter that makes up a large part of our universe, has some strange, unexpected characteristics. Finally, Einstein's theory of gravity may be incomplete. If the universe is expanding, the part of the universe that we see in the past used to occupy much less space. The application of general relativity even leads to the conclusion that this volume was zero and the density of matter was infinite, which is most likely a proof that Einstein's theory is not a final theory and will have to be reconciled with the quantum theory, which so far has not been successful. Most people misunderstand what the Big Bang was. 13.8 billion years ago, this part of the universe that we observe occupied a space with a volume close to zero, but even then, the whole universe was most likely infinite. The expansion of the universe is based on the formation of new space, not on the force separating galaxies from each other. Modern physics doesn't answer our most important questions. The main conflict between people concerns the question of whether so-called matter, as we know it now, is all that exists, or whether there is something more subtle besides it that affects matter but can exist independently of it. The currently very popular among physicists string theory postulates the existence of additional 7 dimensions that only appear in the microscale. Physics opens up to new worlds. In the case of string theory, this is probably a dead end, but it is a conceptual advance. So far, physics has rather blocked our imagination and was used by those who thought that science discovered most of what could be discovered to undermine the value of life. This intellectually primitive attitude has appeared many times in the history of mankind. Even if we assume that consciousness is a product of what we consider matter, it does not exclude that its creation may be an entry into this second, more subtle realm, and somehow makes our existence, or at least its most essential part, independent of so-called matter. It is even conceivable that the rise of consciousness can be initiated in this subtle realm. We do not know what part of the knowledge available to us is what we have already discovered. There is an infinite number of theories describing what we still don't know, which are consistent with what we have discovered so far. It's just a matter of imagination. There is also an infinite number of initial conditions and postulated unknown to us laws of physics that could be in force in the period when density of matter was much greater than that what we could recreate so far in laboratories, which are consistent with all our knowledge about how universe later evolved. Big Bang, understood as the creation of everything from nothing, is one of an infinite number of possibilities. According to many physicists, it is logically contradictory, but very fashionable, mainly because of its simplicity. For today, we only know that around 13.8 billion years ago, this part of the universe that we observe had a volume close to zero, though the whole universe was then more likely infinite. Close and not equal to zero. What happened before we do not know, because we do not know the laws of physics and the states of matter that it adopts at even higher densities. Our two main theories that we use to go back in time, general relativity and quantum theory, at higher densities of matter break down, and we need a theory that reconciles these two theories, the so-called quantum theory of relativity. For the same reason, we cannot explain the state of the matter inside the black holes. We have to distinguish between what is our knowledge and what is only a theory. We don't even know what it means to exist. We have to ask whether existence of universe is possible without a conscious observer. What would it mean to exist if nobody knows about it? We must be prepared that the answers to our most important questions may be beyond our imagination. During last 2 centuries, mankind gathered vast knowledge about the world, but there is no answer to our most important questions. We don't know why the universe exists. We don't even know what it means to exist. We believe that we are alive, but we don't know if being alive is important for this universe. If life was important, we would expect that it was a common phenomenon in this universe, but so far we haven't detected any signs of life outside the Earth. We are looking for life in the universe because we want to know the answer. Modern physics explains most of the phenomena with great accuracy, but no laboratory has been able to recreate anything alive based on the known laws of physics. What is even worse, according to these laws, a human being is no different from a complicated robot. We can't be surprised that billions of people don't accept such dehumanized science. Sometimes it may seem that the goal of many scientists is to undermine the meaning of life. Billions of people think that if there was only what science has discovered, human life would be meaningless. We can't be surprised that they believe that apart from what we know, there is something that gives meaning to the existence of this universe and our lives. we can't be surprised that billions of people think that matter described by physicists is not everything, because they can't imagine that something what is alive arises from dead electrons and quarks. The concept of soul is an attempt to transform picture of human being as a complex robot emerging from modern science into living creature. The reaction to dehumanized science is the dehumanization of matter. Both attitudes are definitely wrong, and conflict between them is destroying humanity. The concept of soul is probably the wrong answer to this problem, because physicists discovered the four main forces: gravitational, electromagnetic, strong and weak, and no other interaction was needed to explain any of the trillions of experiments performed. A lot of so-called souls were present during these experiments, and they didn't affect the results. If soul existed in the form as people imagine it, and would somehow affect the matter that makes up our body, it would have to require an even weaker interaction than a weak interaction, if so far nobody found it, practically having no effect on behavior of our material part. If this reasoning is true, it might seem that there is no such thing as soul, and living creatures could be compared to complex robots, and consciousness is merely illusion. That it is only one of processes supporting life functions with some degree of autonomy. But that conclusion also might not be true. Some physicists allow the possibility that a new quality emerges in more complex material systems, such as humans, for instance. Quantum effects, and especially quantum entanglement, can, according to them, produce a coherent structure with features that do not exist for a single particle or for systems consisting of much smaller number of particles. It is very likely that both of the main philosophical attitudes adopted by people, I mean people who believe in existing of a soul and atheists, result from a false perception of reality. The former group perceives so-called matter in a primitive way and looks for quality beyond it, while the latter group perceive matter equally falsely, but accept the lack of quality of their own lives, what very often leads to moral relativism and depreciating the value of life.